Hi there, welcome to the lesson on first order differential equation. In today's lesson, we will focus on separable equation. In this lesson, you'll learn to identify separable equation and solving them. By the end of this video, you'll have a better understanding of what is separable equation and how do you do them. For this topic, you have to know what is the dependent and independent variable. For the normal differentiation, you have your dx over dy. For this case, the dx is your dependent and your dy is your independent. You have to remember it's always dependent over independent, or you can remember the short form which is d over I. So, what is separable equation and when do you use separable equation? For this case, there's two rules to follow. Rule number 1, only first order are allowed. And rule number 2, able to separate dependent and independent variable. If you have fulfilled these two rules, you are able to use separable equation. What is the order? In order to know the order for the equation, you have to know the basic first differential equation, second differential equation, and much more. So here are some examples for you to see. Look at example 1. You realize it's a second differentiation, which means this is a second order. Take a look at example 2. You realize that this is the third differentiation, which means this is the third order. You do not need to care the power for outside the bracket, because that's not what we are looking for. And this is second order. And lastly, we have the normal dy over dx, which is your usual first order. Now that you have known what is the first rule about first order, we can go on to the second rule, which is separate dependent and independent variable. How do you do that is by making it into the standard form, which is your left hand side is the dependent variables only, and your right hand side is only your independent variables. We have some examples on the next slide. We can now proceed to identifying separable equation with the aid of the two rules. Here's the first example. You realize that now is y prime instead of dy dx. You can actually convert y prime into dy dx. After converting, you have a better view of dy dx. You know which one is your dependent and which one is your independent. You can proceed to shifting them to the left hand side and the right hand side. First, we will bring the 2y minus 4 to the left hand side. And then we will bring the dx to the right hand side. It will become integration 2y minus 4 dy equals to integration 3x squared plus 4x minus 4 dx, which means you are able to separate dependent and independent variable, which means this is a separable equation. Let's take a look at example 2. You realize in this case, the equation has already been put to dy over dx, and this is already the first order. We can go ahead to shifting this equation now. What we want to do now is shifting the dy over dx to the left hand side. We will bring the 2x to the right hand side. Now that we have done that, we can shift the 7y to the right hand side as well. Now that we have dy over dx squared, we can get rid of the square. The equation will now become dy over dx. From this step, we can separate the dependent and independent variable. Now that you have gotten your final answer, which means you are able to separate dependent and independent variable, which means this is also a separable equation. Take a look at example 3. you realize that this is the third differentiation, and this is also the third order. According to the rule, you can only use first order, which means you are unable to do separable equation. Thus, this is a non-separable equation. Now let's take a look at example 4. This question is slightly different. Although you have your dy over dx, which is the first order, and it seems like you are able to separate dependent and independent variable. So let's try out whether we can separate them. First, we shift the dx to the right hand side. Then, we shift the x to the left hand side. We'll come to get an answer that we cannot separate, which means this is non-separable equation. From those previous examples, you'll come across the final answer which requires integration. In order to do integration, we have to recap on the formula. Here we have the formula. You have the x to the power of n, which is the power. You have to add the power by 1 and divide it by the new power below. By remembering this formula, we can go ahead and try others question now. Now, let us take a look at some different examples. Look at example 1. You realize there's a given condition now. But let us do the separable equation first. In this case, we have dy over dx equals to 6y squared x. dy over dx is the first order, which means we can separate the dependent and the independent variable. Let's go ahead by doing it. We have the dx, which we can shift to the right hand side. After shifting, we get a new equation. We can go ahead now and shift the y squared to the left hand side. After doing those shifts, we get a new answer. We will get two integration answer. How did this y to the power of negative 2 came about is by shifting your y square up. And now we can do integration following the formula, which is power plus 1 divided by new power. Remember to add plus c after you have done your integration. We have the final answer, which is negative 1 over y equals to 3x squared plus c after simplifying. Now we can go ahead and do the condition, which is when x equals to 1, y equals to 1 over 25. So let us sub in all those numbers. So we have the numbers sub into the equation, can go ahead and solve it. We can find our c, which is negative 25 minus 3, which gives us the answer negative 28. And now we can go ahead and solve y. Now is y equals to negative 1 over c plus 3x squared. We have the previous answer, which is c equals to negative 28. So let us sub in the value now. So our answer for y now is 1 over 28 minus 3x squared. Let's take a look at the last example. Remember the steps we are supposed to do? We are supposed to go according to the rule, which is identify is this the first order. Take a look at dy over dt. You realize that this is the first order. So we can go ahead and try the others. What we want to do now is shifting dy over dt to the extreme left hand side. So we'll shift the -6 to the right hand side. And now we'll shift the 12y to the right hand side as well. Now that we have dy over dt, we are very close to what we want. We can simplify this whole equation first by dividing into 3. After simplified, we can get rid of the dy over dt squared by shifting it to the right hand side. Now the right hand side will be square root of everything. Since it's square root of everything, we can break it into two parts. Square root the top, square root the bottom. Now we can go ahead and separate the dependent and independent variable. We'll start off with the square root 4y. Now that we have the two answers of integration, square root 4y and plus minus square root x plus 2. We can now break the square root 4y into square root 4 times square root y. We can go ahead and simplify it, which will give you 2 square root y dy equals to plus minus square root x plus 2. In order to do integration, we need power. So we can convert the square root y into y to the power of half. By doing so, we can go ahead and do integration. Power plus 1 divided by new power. And when you solve it out, you'll get your equation. You can take the 2, multiply to the front. And you can take the 4 over 3, divide to the right hand side. And now you got your answer for y, which is y to the power of 3 over 2 equals to plus minus 2 over 3 x plus 2 to the power of 3 over 2 plus c over 4 over 3. You have now solved this. So now that you have finished learning, you can proceed to some mini tutorial where you can try out some question. There will also be guide teaching on the question. Now that we have learned how to use separable equation and how to identify them, we can go ahead and solve new questions. Before we begin, let us recap on the rule. The first rule is we can only use first order. The second rule is we have to separate the dependent and independent variable. Let's take a look at example A. We have dy over dx equals to x squared over y cubed. You can now go ahead and try out this question first while pausing this video. After you have done so, you can come back and see the steps that are provided here. So we can go ahead and take a look at this. We can identify that this is the first order, and we can go ahead and separate the dependent and independent variable. For your dependent is your dy and your independent is your dx. You can go ahead and bring y cubed to the left hand side and dx to the right hand side. Which will give you y cubed dy equals to x squared dx. And now you have to integrate both of them. Which will give you y to the power of 4 over new power of 4 equals to x cubed over 3. And remember to write plus c after you have done integration. So there you go, your answer. You can also simplify this question by moving the 4 underneath the y to the power of 4 to the right hand side, which will give you 4 times x cubed over 3. Let us now take a look at example B. We have x minus y squared times dy over dx equals to 0. You can now go ahead and pause this video again and try it out yourself. And come back here when you have done your question. Alright, now we can identify if this is the first order. As you can see, this is dy over dx, which is the first order. So we can go ahead and separate this independent and dependent variable. We first start off with the x, which will move to the right hand side, which will give us the new equation y squared dy over dx equals to negative x. We can now go ahead and shift the dx to the right hand side as well, which will give us the new equation negative y squared dy equals negative x dx. And you have to integrate both of them, which will give you the new answer negative y cubed over 3 equals to negative x squared over 2 plus c after you have integrated. You can go ahead and try the next step, which is to get rid of the negative sign, you have to shift both of them, which will give you them positive y cubed over 3 equals to x squared over 2 plus c. We can simplify this equation by moving the 3 underneath the y cubed to the right hand side as well, which will give you y cubed equals 3 times x squared over 2. So now let us take a look at example C. In this example, it will be slightly different. We have dy over dx equals to 3x squared y squared given a condition, which is given y 0 equals to half. We can go ahead and identify this. Is it a separable equation? You realize that it's a first order and there is dependent and independent variable. We can go ahead and shift this by shifting y squared to the left hand side and dx to the right hand side, which will give you a new equation. So you have dy over y squared equals to 3x squared dx. You have to integrate both of them now. In order to do integration, you must have power. So in this case, we can shift the y squared upwards, which will give you a new equation, which is y to the power of negative 2 dy equals to 3x cubed over 3 plus c. We can integrate the second part because it already fulfills the criteria. We can go ahead now and integrate the first part, which will give us y to the power of negative 1 over negative 1. We can now shift the y back down. And now we can find the value for y, which is y equals to negative 1 over x cubed plus c. So now that we have solved that, we can go ahead and solve the condition, which is when y 0 equals to half. So we can go ahead and sub all this value in. Y equals to negative 1 over x cubed plus c, which was done earlier on. So we can go ahead and sub now, which is half equals to negative 0 cubed plus c, which will give you the answer negative 1 over c equals to half, which means c equals to negative 2. And that's how you solve. We have now come to the end of the lesson. I hope you have understand better on separable equation and how to identify them and solving them. Thank you.